this says 4 years, and since this is compounded annually, it's fine. It doesn't change anything. But if this was saying this said 4 months, you would have to convert the 4 months into years, or it wouldn't work. All right, so n is 4. So we have everything but I, which is exactly what we are looking for. So the first step is to divide both sides by 8,000. All right. And I don't have a calculator with me. Wait, what's going on? Oh, there. So there we go. All right, so we're gonna have 11,501.24 divided by 8,000. Answer. Wait. Oh, wait. There you go. All right, so that's going to be 1.437655. Is equal to 1 plus I to the power of 4. Here, when we're solving for a value that has an exponent, this is what we did in the exponential unit. It's because we learned about exponent laws and we learned about logs. We're going to take the log of both sides. If you don't remember, that just means that write log in front of everything on both sides. And the special property with logarithms is that if the term inside the log has an exponent, I can take that exponent and write it in front of the log sign. So this becomes log 1.437655 is equal to 4 log 1 plus I. And that 4 is gone. It's in front now. And we can now divide Oh, wait. We don't need to use logs. I'm so sorry. You only use logs when the unknown value is in the exponent, when you're solving for n. That's the only time you need to use logs. But we are given n. We know the exponent. We actually just take the 4 on this side. We just take the 4th root. One plus I. That's it. Yeah. Yeah, so you only use logs when you're solving for an unknown value in the exponent. All right, what's the 4th root of this value? 4th root, let's see. So 4th root of answer is 1.09, this value here. Can I copy this somehow? Maybe, I don't know. Oh yeah, perfect. Okay, so this is equal to 1 plus I. So this is this number, 1 plus I is equal to that. I is equal to 1.09499. I'm just going to round there. Minus 1. So you obviously take away 1, and then you're just left with the decimal. 0.09. I'm just going to round to 5. Which is your I value, but if we want it in percentage, we just multiply it by 100%. So your interest rate is actually 9.5%. That's the interest rate. Which honestly, in today's days, isn't bad. So 9.5% interest rate. here we have the solution, and they got 9.5% as well. So yeah. All right, that's it for compound interest. Let's move on to some more difficult stuff. Part 3, present value. Okay. Oh wait, this is an investigate question. Oh, sorry, we're not doing investigate. We're going to do an actual question. Here we go. We got a question. Calculate present value. Sahara wants to invest money today to have $1,000 in 6 years. If she invests her money at this amount per year, compounded quarterly, how much does she need to invest? Ooh, so here we have a good question. To see how 6 years and compounded quarterly are different. So we're gonna have to do something about that. So let's do that right now. So first things first, what's the formula? It's the same formula as this one here. Question is, we're calculating present value. We're looking for P. And the thing is, right now, the way this equation is written, it's solved for A, or future value. So we need to rearrange to solve for P. So all you really have to do is take this term and bring it here. So P is equal to A over 1 plus I par ben. That's it. Just rearrange the equation. It's the exact same equation, just rearranging it to make it easier. And now we just plug in all our values. She wants to invest it to have 1,000 in 6 years. So I know that A is $1,000. I know N is 6 years, but hold on. What's my J value? Compounded quarterly. So J is 4. So N, that's going to be 6 times 4, which is 24. My I value is 5.75%. But remember, I don't know if you remember, but you're supposed to actually take your I value and first things first, always convert percent into decimal. So 0.0575 and then divided by your J value, which in this case is 4. So 0.0575. Oh man, didn't copy this time. That's fine. 0.014375. All right, so that's my I value when it comes to plugging it into the equation. Because remember, it's always N times J and I divided by J. So now my equation becomes $1,000 over 1 plus 0.014875 to the power of 24. Okay, this is a calculation, so let's just do this. Plus